Now let us see another problem and try to find out what is the stability of the system using Nyquist plot. And of course, we can certainly know the stability of this particular system since you already studied different ways of finding the stability of system. Before we actually start the Nyquist plot, so we should be at least having a feel of okay, what now is the stability of the system. Looking at the open loop positions and the system gain or the root locus gain of the system. Suppose if you actually see the what poles zeros of the open loop system, so you have one at 6 here, this is at -4. We know that centroid will be there onto the right hand side of the S plane. Okay, we know that this is S plane here, and this is -4, and we are supposed to get a root locus which is coming like this, and has to be on the, of course, depending on where is your centroid and the asymptote. So it may just go like this, or it may just go somewhere like this. But it is interesting to see for large values of the root locus gain, both the poles come to the right hand side of the S-plane. So system is a conditionally stable system. For lower values of K, system is of course, now you can see system is absolutely stable. It's not even condition stable, because one of the pole is always there onto the right hand side of the S-plane. System can never become stable. So meaning system is absolutely unstable. Now absolutely unstable because of what? Whether you have one pole to the right or two poles to the right, that depends on the value of this 50. This K value. If this K value is very small, at least one is there on the right hand side. If K value is very large, then it is onto the both are onto the right hand side of the plane. Now the question is, we need to find out system is unstable because of how many poles going on to the right hand side of the plane. So let us try to find out how do we plot the Nyquist plot for this particular transfer function. So now again, as usual, we start with the location of poles and zeros of the open loop transfer function in the S-plane. As I already mentioned, it is -4 and +6 is the location of poles in S-plane. Let me write the Nyquist contour, which is covering the entire right hand side, starting from, of course, this is infinite, so we are treating this as infinite. Of course, this is J, this is also J, this is going up to infinity. This is segment 1, this is segment 2, segment 3, this is your contour. Looking at this, since one pole is there onto the right hand side, it is enclosed by this Nyquist contour, so this P becomes 1. We need to find the value of n so that we can estimate the value of z, which is n plus p. To know the value of n, we need to map each and every segment of this Nyquist contour onto GH plane and look at that -1 plus j0. Whether it is n circling, whether it is n circled by the contour in GH plane or not. So for that, mapping the first segment, so what we are doing, we are replacing S by j omega. So let me do the same thing. Let me write the magnitude is nothing but, so let me first write replace S by j omega. It is now 50 divided by j omega plus 4, and it is j omega minus 6. So let me know the magnitude of this, which is nothing but 50 divided by under root of omega square plus 4 square divided by omega square plus 6 square. So magnitude doesn't matter whether it is -6 or 6, so it is so and so. But for phase, it matters a lot. So now it is, phase is what? So it is tan inverse of, so now it is minus tan inverse of omega by 4 minus of tan inverse of omega by -6. Now this -6 need to be properly considered to write the phase equation. So it is now minus tan inverse of omega by 4 minus of 180 degree minus tan inverse of omega by, okay, this is omega by 6. So let me rewrite this. So this equation becomes, phase equation becomes minus tan inverse of omega by 4 minus of 180 minus tan inverse of omega by 6. So this ultimately becomes minus 180 minus tan inverse of omega by 4 plus of tan inverse of omega by 6. So now let us give different values of omega and try to find out what is magnitude and phase at different omegas. So let us first do it for extremes. This is magnitude and phase. This is 0, sorry, not degree, radian per second. This is infinite. So when it is 0, you know that it will be 50 by 24. It is 50 by 24, almost just, okay, 2 point something. Now this is, if you can see, this is, suppose if omega is 0, these two are 0, it is now minus 180 degree. And it is when infinity, or when these magnitudes will become infinity, then it is 0 magnitude, and phase is again, this is minus 90, this is plus 90, this is again minus 180. So it is interesting to see that starting phase is also minus 180, final phase is also minus 180, but the magnitudes differ. Now we need to find out for smaller values of omega what will be this phase. Suppose if you look at this, here this is dominating compared to this, that is negative term dominates over the positive term. Here it is omega by 4, this is omega by 6. So naturally, so this has to, when this is dominating than this, so do you feel that for lesser values of omega this is like becoming minus 181, minus 182, so on so, meaning of course no need to even calculate also. So what you can simply write is, this is minus 181 for maybe a small value. So this is a small value, it can be 0.1, 0.01. So this is the indication looking at this is stronger compared to this, because this is omega by 4, this is omega by 6. So omega by 6 is lesser compared to omega by 4, so that this dominates. So it is now more negative than minus 180, so that's why it is minus 71. Meaning this, suppose if I want to write the GH plane, in the GH plane I should plot this one. Now it is 50 by 24, let me write, it is 50 by 24 is 2.08, and the magnitude is minus 180, you are there here, it is 2.08 at an angle minus 1, it is this point. Now you can see this is the value, and you can see the angle is going minus 180. So this is actually 0 degree, this is minus 90 degree, this is minus 180 degree, this is minus 270 degree. So where is minus, okay, this is actually 2.08 minus 180. So where does minus 181 come? It will come in this second quadrant. So it actually goes like this. It actually goes like this, and then again it just comes to minus 180 and the magnitude becomes 0. So this is what the plot is. This is the first segment. This is the first segment of this contour in GH plane. So to find the second segment, you replace S by r e power j theta, where r is tending to infinity and theta is varying from plus 90 degree, 0, minus 90 degree. So what will happen to this? This will give a magnitude of 50 divided by r e power j theta plus 4 r e power j theta minus 6. Of course this and this are negligible compared to r e power j theta, then this becomes tending r applying tending to infinity, this will become 0 at an angle minus 2 theta. So since we know that theta is varying from 90 so on, so this will become 0 at an angle minus 180 degree through 0 and plus 180 degree. Whatever the angle, since the magnitude is 0, it's a point at this point. It is interesting to see that wherever this ends 0 at an angle minus 180, this has to start. Can you see the ending point and starting point of segment 1 and segment 2 should be the same. This is where your first segment ends, this is where your second segment starts. And we know that this is your the second segment mapping. Third segment mapping, as we know, this is just the mirror image, so it just goes this way. This is actually going here. So whereas since it is 2 at an angle 2.08 at an angle minus 180, so minus 1 is, this is actually minus 1, which is nothing but 1 at an angle minus 180 degree. So since this, can you see, this is actually encircled, or this contour is encircled this minus 1 plus j0 by 1s, so n is equal to 1. So what was the value of p? P was 1, and we found that n is becoming 1, so this becomes 2. Meaning, as we are just discussing before we start plotting this, z should be either 1 or 2. Since the value of this k value is 50, which is more large enough, this pole has also come towards right hand side of the plane. So that's why the z is becoming 2. So that's why you can see z is actually 2 now here. So z is actually 2 now. Now what is the gain margin now? So gain margin is actually, okay, now if you look at this point, since the system is unstable, so what is, okay, how do you find gain margin? So gain margin is actually, so now since the value of p is already 1, so this is actually minus infinity, because you can never make the system stable by reducing the gain to whatever extent. Even if you make it 0, system is still unstable. So in this case, finding the gain margin from the plot doesn't have any sense, because system is absolutely unstable. Only for conditionally stable systems we can find the gain margin from the plot. Since in this case, since it is absolutely unstable, gain margin is minus infinity. But you can certainly find the value of phase margin. So phase margin, as you know, it is 180 degree plus phase at omega gc. So what you can do is you can find out the phase at which magnitude becomes 1. So that you can do it by this method. So what I do is I just equate this to this, find out the value of omega at which the magnitude becomes 1. So if I just find the value of omega gc, so how do I find omega gc? I just equate these to 1. So this omega become omega gc. So it is now 50 divided by, okay, so what I do, 50 alpha equals, open the parenthesis, under root of alpha a square plus 4 square, close the parenthesis into open the parenthesis, square root of open. It is alpha a square plus 6 square, close, shift cal. Now we are trying to find what is omega gc. Omega gc is 4.99. So omega gc is 4.99, at which magnitude is 1. Let me find what is the phase at 4.99. So what I'll do, okay, this is minus 180 minus of tan inverse of, okay, alpha a by 4 plus of tan inverse of alpha a by 6. Calculate for this. So it is minus 191. So it is minus 191 degree. So now coming to this, so this becomes 180 plus of minus 191, so that will become minus 11.5 degree. So since gain margin is minus infinite, dB or minus infinite, so what is phase margin? Phase margin is minus 11.5 degree. System is unstable. Now system is unstable. So this way we can able to, of course, this negative sign is making your P equal to 1, so on. So suppose instead of making this as 50, suppose if I consider it as only 5, so if I just take it as only 5, so will it become actually 0.208 at an angle minus 180, because this you are reducing it by 10. So when it is this, so then minus 1 will come outside, so then n becomes 1, sorry, n is 0 since it is not encircling. Since suppose if this is instead of 50, if you make it 5, instead of 2.08, this will become 0.208, then it's not encircling, then n is 0, p is already 1, so z becomes 1. So as we predicted earlier, even for lower values of k, you have one closed loop pole lying to the right hand side of the plane, which is true here, from this calculation. For even lesser values of n, this, even though it may not encircle, since p is 1, z will become n plus p. So even though n is 0, so p is always 1, so that z becomes 1. Okay, this is going to make you people understand the concept. Let me do one more video in the next